How do apothem, radius, and side length relate in a regular octagon? Imagine building a perfect octagon and wanting to know how its inside measurements connect. It's like solving a puzzle where each piece fits perfectly with the others. When you look at a regular octagon, all sides are equal, and all angles are the same. The key measurements are the side length, the radius, and the apothem. The side length is how long each of the 8 sides is. The radius is the distance from the center of the octagon to any of its corners or vertices. The apothem is the distance from the center to the middle of any side, which is also the radius of the circle inscribed inside the octagon. Now, picture dividing the octagon into 8 identical triangles. Each triangle has its tip at the center, with 2 sides equal to the radius. The base of each triangle is one side of the octagon. The central angle of each triangle is 45 degrees because the full circle around the center is 360 degrees, divided by 8. When you split one of these triangles in half, you get a right triangle with an angle of 22.5 degrees. The apothem is the side adjacent to this angle, and the half of the side length is the opposite side. Using basic trigonometry, the apothem equals the radius times the cosine of 22.5 degrees. The half of the side length equals the radius times the sine of 22.5 degrees. From this, you can find the side length by multiplying 2 times the radius times the sine of 22.5 degrees. Similarly, the radius can be found by dividing the side length by 2 times the sine of 22.5 degrees. The apothem can also be expressed as the side length times the cotangent of 22.5 degrees, which is the cosine divided by the sine. If you want to get a rough idea, the sine of 22.5 degrees is about 0.3827, and the cosine is about 0.9239. The cotangent is approximately 2.414. So, the radius is roughly 1.3 times the side length, and the apothem is about 1.2 times the side length. These relationships help you understand how the measurements of a regular octagon fit together. If you know one measurement, you can find the others easily, which makes working with octagons much simpler. Understanding these connections makes it easier to calculate the area of the octagon or to draw it accurately. The radius is always longer than the apothem because it reaches the corner points, while the apothem only reaches the middle of each side. The side length relates to the radius through the sine of 22.5 degrees and to the apothem through the cotangent of 22.5 degrees. These relationships come from dividing the octagon into 8 equal triangles and applying simple trigonometry. Knowing how these measurements connect helps you see the octagon as a balanced, symmetrical shape where every part is related to the others in a clear, predictable way.